Hi guys. I'm coming to you all gorgeous and sweat panty, but I wanted to hop on and I wanted to go over the information that I would have been covering in class today because your test still is going to be on Friday unless I hear we have some other issues with the school. So I wanted to go over boiling point elevation and freezing point depression. So I'm going to show you how to work through the problems, and then I'm going to send you the download of the worksheet. So this way you can have a jump start on it because I know you have another free day of school, off of school, but we do have to cover it. So hopefully there's only 6 problems, so it's not overwhelming. And this will give you hopefully a good firm foundation so you know what to expect, right? Okay, so this is the worksheet I'm going to be sending you. It is only 6 problems, so it is 2 pages, but it's only two problems per sheet, so 3 pages. Okay, so the first question says, what is the freezing point of a solution of a non-electrolyte dissolved in water if the concentration of the solution is 0.24 moles? Okay, so we are looking for freezing point, okay? So we want to know freezing point. So what is the freezing point? That's what we want to know, okay? So it says it's a non-electrolyte. So that means it's not ionic. It's not going to break down into ions. So anytime you see the word non-electrolyte or covalent, we know we're talking about that I. Remember we talked about the I? Maybe not from class. So our equation, we're talking about freezing point. We have to remember delta T, okay, change in temperature of freezing, so that's little f, equals I, so little I, K is our constant, okay, and so we're talking about freezing, so it's little f, and then molal, so M. That's your equation. I delta TF equals I KFM. Okay? So when we're talking about a non-electrolyte, if you have a non-electrolyte, your I is always going to be 1. Always, always. So in this case, we don't know, where do we have to find this guy? This is what we need to know. In order to find the freezing point, we need to find the change in the freezing point temperature. So we do know I is going to be, in this case, 1, okay? Our KF, now this is our constant. So I will provide that for you. So you're not going to have to memorize it. It's kind of easy to remember once you do it a couple times, but I'll give it to you. So if we're talking about the KF, so the constant of freezing, we're using water, okay? So if it's a different solvent, you would be told that, and you'd also be given that constant, because really you would just use a table to figure out what the normal freezing point is for that solvent. So in this case, it is 1.86 degrees Celsius per mole. Okay, that doesn't look like a 6. 1.86 degrees Celsius per mole. Now, we're given what molal is, right? What did I say it was? It is 0.24. So 0.24 moles. So you see, if you look at the information, look at your equation, these are all the different variables you have. You know 3 of the 4, so we need to solve for delta TF. Okay, well that's easy. Delta TF equals we know what I is, so it's 1 times 1.86 degrees Celsius per mole times molal, 0.24. You see that your M's will cancel, your molals will cancel, and you'll be left with a unit of degrees Celsius. So if you plug this in, delta TF equals, what does it equal? 0.45. 0.45 degrees Celsius. Okay, paying attention to 6 things. This has 3, this has 2, our answer has 2. So you might be tempted to say, well, that's the answer. But that's not the answer. The answer is what is the freezing point? So in other words, what is the new freezing temperature? So if we're talking about water, water has a freezing point of 0 degrees Celsius, right? That's when water freezes. So when we're talking about freezing point, we want to say, well, how much is it lowered? It's going to be lowered, so our number's going to get smaller. So in this case, the new freezing point, all you have to do is, it's basically the difference. So you're subtracting. So instead of being 0 degrees Celsius, our new temperature will be negative 0.45 degrees Celsius. Because if we're changing it by 0.45 degrees Celsius, that means we are lowering the temperature. If we're at 0, and if you go past 0, you go into the negatives. So negative 0.45 degrees Celsius. That would be your new freezing point. I hope that makes sense. Okay, so that's problem number 1. Let's move on to problem number 2. Okay, number 2. How much will the freezing point be lowered if enough lithium sulfide is dissolved in water to make a 0.50 molal solution? This requires you to know how to name compounds, right? So lithium sulfide. Lithium sulfide. If you are still struggling, you really need to take these steps. If you see the word lithium sulfide, the first thing you want to do is say, well, what elements are involved? Lithium's involved and sulfur is involved. So let's write the symbols for those 2 elements, okay? So then lithium. If you don't know what lithium's oxidation state is, what do? Your best friend, find lithium. Group 1. Okay, its oxidation state, +1. Write it down. Sulfur, over here, okay, that's a -2. -2. Crisscross the applesauce, right? Li2S, right? All we did was crisscross. Li2S. So now we know we're using lithium sulfide. Okay, that's what we're working with. So now, we're talking about freezing point again. So let's say we know our equation, delta TF equals IKFM. So now we need to start identifying what we have. We're talking about what's the freezing point, so we need to know this. Delta TF equals question mark. Okay, the first thing I come to is I. Do I know I? Wait, I do, because I know this, so I can figure out what I is. I equals Li2S is ionic, which means when it is placed in water, it's going to dissociate. So the ionic compound is going to break down in individual ions. So to determine your I, you have to say, well, I have Li2S. Remember I said in class, all you do is add your subscripts. So in this case, I have 2 lithiums. I have 1 sulfur. So this is my subscript of 2. This is essentially a 1. We just don't write it. So 2 lithiums and 1 sulfur. That equals 2 plus 1, which means I is going to be 3. So if this goes into water, this will break into 2 lithiums and 1 sulfur ion. So I equals 3. Okay? KF, that's the same value that we've used. It's a constant, 1.86 degrees Celsius per molal. And then our molal was what? 0.50. 0.50 molal. So now we're in the same situation we were before. We just plug and chug. Solve for delta TF. Delta TF equals 3 times 1.86 degrees Celsius per molal times 0.50 molals. Molals cancel out. Delta TF equals 2.79. Okay, so now looking at this, is that going to be your answer? Should I say it's 2.79? Should I? Well, let's look at this. We have, this is a counted number, so we don't count it, okay? Here's 3 sig figs, here is 2 sig figs. So if we're multiplying, we need to make sure our answer is 2 sig figs. So delta TF equals 2.8 degrees Celsius, okay? Now that's just the change in freezing point. So remember, this means change, not new. So we're talking about water. We're dissolving lithium sulfide in water. Water has a normal boiling point of 0 degrees Celsius. So if I change the freezing point by 2.8 degrees Celsius, freezing is a lower temperature. So the new freezing point is negative 2.8 degrees Celsius. Okay? That is your answer for number 2. Okay, I'm erasing. Hopefully you have this written down, but you can pause if you can even see it. I don't know. Hopefully you're following along. Okay, moving on to the last one of freezing. Okay, so what is the freezing point of a solution that contains 68.4 grams of potassium bromide dissolved in 1.00 times 10 to the second grams of water? Okay, a little bit harder. Have to do a little bit more work. First thing first, what are we working with? Potassium bromide. Okay, potassium bromide. So we're dealing with potassium and bromine. This ide, okay, you should be able to see that this is ionic. Potassium is K, bromine is Br, potassium is a +1, it's a -1, you crisscross, we're dealing with KBr. Now I've just named it. That's good. We know it's ionic. Okay, so our I is not going to be 1 because it's ionic. It's not a non-electrolyte, it is an electrolyte. Okay, so we're still dealing with freezing, so we have to, make our little key. We don't know this. IKFM. So, can we identify I? We can. KBr. Add your subscripts. This is 1 and this is 1, so our I will be 2. I is 2. This will break into 1 potassium ion and 1 bromine ion. Okay? KF, still dealing with water unless told otherwise. So it's 1.86 degrees Celsius per molal. But we don't know molal. What we do know is that we have 68.4 grams of potassium bromide, and it's in 1.00 times 10 to the second grams of water. So we know, what do we know? We know 64, no, that's not right. 68, where's my eraser? 68.4 grams of KBr. And we know 1.00 times 10 to the second grams. Well, we're looking for molal, and we know, because we've done it, that molal equals what? Is it moles? Maybe. Moles per what? Kilograms. Okay, so moles of solute over kilograms of solvent. Okay, so in this case, do we know moles? No, we don't. Do we know kilograms? Not really. No, we don't. But we can figure those out. So let's start with our grams of KBr. We have 68.4 grams of potassium bromide. And we want to know how many moles that is. So just stoichiometry, real simple. We would find the molar mass of KBr, which I'm going to do for you. 119.002 grams. So 119.002 grams of KBr. That's 1 mole of KBr. That ends up being 0.575 moles of potassium bromide. Okay, so now you have moles. The other thing we have to do is we don't have kilograms, we have grams. So we have to change our solvent into kilograms instead of grams. Hi, Noah. Want to say hi? Want to say hi to the kids?
What?
Want to say hi to the kids? No. He's shy. Come say hi.
To who?
I'm just doing a video. They'll watch it. Just come say hi.
Hi.
Okay. Go away now. Be gone with you. Go do school.
Yeah.
Okay. So 1.00 times 10 to the second grams of H2O. All right. We just need to make that into, lost my train of thought with my kid coming downstairs. We just need to make that kilograms. So if you're not sure how to do that by just like moving the decimal, remember, you can always rely on breaking it down. Grams we want to get rid of, we want to get to kilograms. Okay? We have 1,000 grams is always 1 kilogram. Okay, if you do that, what does it come out to? It's 0.100 kilograms of H2O. Okay? So now we have things in terms of moles and kilograms, so we can solve for molarity. So the molarity equals moles, 0.575 moles over 0.100 kilograms, which is just 5.75. 5.75 little m. Okay, so I'm going to put that over here. 5.75 little m. Okay, so I'm going to erase all of this. I'm going to leave my key here, and then I'm going to work the problem. Okay, because my board's little, and I write big. Okay, so now delta TF equals I KFM. Okay, we're solving for this. So delta TF equals, what's my I? My I is 2 times 1.86 degrees Celsius per molal times 5.75 molals. Molals cancel. Delta TF equals, I should have 3 sig figs, because this is 3 and this is 3. This is a counted number, so it doesn't count as a sig fig. Okay, so my delta TF is 21.4 degrees Celsius. Again, that is not the new freezing point. That is just the change in freezing point. Since it's water, if we're at 0 and we depress the freezing point where we're lowering the temperature, which means this new solution will freeze at negative 21.4 degrees Celsius. Okay, so those are the 3 problems you have in terms of freezing point depression. Okay, so I'm going to stop this one here, and then I'll start up with the new one for the boiling point elevation.